So priority and type of services. Contains total 8 fields. So these 3 bytes belong to these 3 bits belong to priority. So if these 3 bytes are 1 1 1, it means it has a higher priority. If these 3 bytes are 0 0 0, so it means it doesn't have any priority. So it suppose that it is 0 0 1, so it's have a greater priority than it. Okay, are you getting my point? Suppose that p p p, these 3 bits are 0, it don't have any priority. What will be the decimal value of these 3? 0. If these 3 are 0 0 1, so it means it has one priority, means it has greater priority than first one. Okay, are you getting my point?
Yes, sir.
Yeah.
0 1 0, it has a greater priority than 1. 0 1 1, it has a greater priority than 2.
2.
1 0 0, it has a greater priority than 3. 1 0 1, has greater priority than 4. 1 1 0, has a greater priority than 5. If all bits are 1, then what does it mean? It means it has highest priority. Is it clear for everyone?
Yeah.
The next D denotes as delay. We will discuss about delay in more details in EIGRP. Okay, so T denotes D denotes delay. T denotes throughput. R denotes reliability. Okay, C denotes congestion, and O is reserved. It's a reserved bit. Nothing we will have to change in it. Is it clear for everyone? Throughput means how many packets we are sending and how many packets a receiver is receiving. Higher the throughput means higher the receiving chance. If it is 100%, it means no data packet loss. Okay, getting my point? D denotes delay, means what is the delay, how much time it is taking. Is there any delay from a proper timing time of delivery or no delay due to congestion on the route or maybe any other reason. Is it clear for everyone? These are 8 bits for priority and type of services. Guys, please reply.
Yes, sir.
Okay.
Sir, priority have how many bits? Like bytes or bits?
Only 3 bits.
Priority.
Only 3 bits. First 3 bits.
Okay, sir.
So the next is identification. Who will tell the definition of fragmentation? Subhaji, what is fragmentation?
In layer 3, data divided in fragment.
This is also like divides the data
The
into like
process is fragmented.
which works in the layer 3, right? Then
Yes, exactly. Suppose we have a data of 4200 bits. Okay, and we have to send it. So we can divide it into parts. 0 to 1480, 1480 to 2960, and 2960 to 4200. So we are dividing here these data before sending it from a sender to receiver. Okay, are you getting my point? Before sending the data of 4200 bits, we are dividing into chunks. Okay, then we are sending these data. It may be possible that this segment, suppose that it says segment 1, it is a segment 2, it's a fragment 3. Suppose S2 receiving first, S2 is reaching first, then S3 is reaching on R2, then S1 is reaching. By the identification field, by the identification field, R2 will know which one I will have to put first, and after that which one will be second and which one will be third, so that it can comprehend and it can make a meaningful data. Are you getting my point? Subhajit,
Yes, yes, sir.
otherwise if it will arrange it in the same manner as 2, then S3, then S1, will it be meaningful? Suppose that I am sending
no.
Abdul is in USA and USA is reaching first, then is reaching, then in reaching, then Abdul reaching. Will it be a meaningful data? if I am
Yeah.
attaching a identification number here first, here second, here third, and it's fourth. And by seeing this identification field, if a receiver is rearranging the data, then it will be a meaningful data. Is it clear for everyone? Lakshman?
Yes, sir.
Yes, sir. I think it's like sequence number in TCP header.
Yeah, sequence number. Exactly. Ravi Shankar,
Sir.
clear?
Sir.
Any doubt? No?
Sir, identification number helps to rearrange and reassemble the data,
Yeah,
whether it's enough.
yeah. Now we will discuss about the flag. So there are three flags. First one is reserve. Second one is don't fragment. And third one is more fragment. How many flags in IP TCP header? Subhajit,
8.
what are those flags?
That sync act when
Set,
reset, yeah, window size,
push urgent, CW
yeah, then,
broadband, ECM.
and checksum, yeah, thing.
Okay. So reserve field will be always 0. Don't fragment, it can be 0 or 1. More fragment, it can be 0 or 1. More fragment,
So,
more fragments are coming. More fragments gives an information that more fragments are coming. If it is 0, then it means no fragment is coming. If it is 1, then it means other fragments are coming. They are on the path. Is it clear?
Sir, one more time.
More fragment gives an information that more fragments, other fragments are coming or not. Suppose that we have divided a 10,000 bits data into some chunks. Let me give an example to you. 10,000. So 0 to 1500, 1500 to 3000, 3000 to 4500, 4500 to 6000, 6000 to 7500, 7500 to 9000, 9000 to 10,000. Okay, it's a 10,000 bit data. We have done here the fragmentation. What means of the fragmentation, Lakshman? Divide a bigger data into small chunks. Okay, so if this part will reach to the destination, it has a field of more fragment field. And if it is 1, it means other fragments are coming. Okay,
Yes, sir.
and if it is 0, if it is 0 here for this last one, so it means no other fragment will come. It is the final one.
Yes, sir.
Is it clear?
Yes, sir.
Abdul, is it clear also for you?
Yeah.
Subhajit, Ravi Shankar,
Yes. Yes, sir.
Oh,
Understood.
sir, clear, sir.
clear? So more fragment is clear, and last flag is don't fragment. What will be the don't fragment? So anyone who knows about OSPF?
Uh, Open shortest path first. It is an
Yes.
open link state.
So Abdul, do you know about OSPF?
No, no, I don't know.
You don't know. So OSPF is a protocol. By this using this protocol, the routers exchange their routing table and database table with each other. Okay, so before exchanging their database table, there are some states in OSPF so that they can become their neighbor with each other. So one state is two-way state, in which yesterday you were talking, Abdul, you were talking about the in two-way state, they will check their MTU size, maximum transfer unit size. And if for the both router MTU size same, then only they will become neighbor to each other. Otherwise, they will not become as a neighbor to each other. Okay?
I mean, there is no negotiation. Will there be any
Yeah,
negotiation between them?
yeah. They will not send their database table and routing table. They will not exchange their routing table and database table with each other. Okay? So
Mhm.
if MTU size will be same, so similarly, if a router is receiving 1200 maximum, what is the MTU size in segmentation and fragmentation? There is a difference between segmentation and fragmentation. Of MTU size.
Maybe 1460, I think, is it?
1500 bytes.
Yes. Both are correct. For segmentation, how many bits? 1460 or 1500? Guys, please revise the last one.
1460, sir. 1460 for segmentation and 1500 byte for fragmentation.
Yes. So if here, suppose here, router 2 is receiving 1000 bits only. Okay. And it has a capacity of 1500 bits to process 1500 bits at a time. Okay. So it will tell to router 1 there is no need of fragmentation. Directly send it because I can process 1500 bits and you are sending the size of only 1000 bits. Okay, so that is called as fragment. Don't fragment bit. If it is 0 or 1, if it is 0, you need not to perform the fragmentation. If it is 1, means you need to perform fragmentation. I will show you this into the OSPF. When I will teach you the OSPF, then I will show you this thing. Okay? Is it clear for everyone?
Yeah.
Yes, sir.
Okay.
Yes, sir.
The last one is fragment offset. Anyone has any idea about fragment offset? So, identification field, here in the identification field, it has an identification number. Suppose that identification number is 0x001. This one has an identification number 0x002. Suppose that this one has 0x003. This field only have the identification number. With the help of this identification number, fragment offset perform the rearrangement of data. Requirement of two things. That is more, first it will check more fragment are coming or not from the flag. Remember, do you guys remember here we discussed more fragment are coming or not? If this field is 0, it means more fragments are not coming. If it is 1, it means more fragments
Fragments are
are
coming.
coming. Okay, so by using this identification field and more fragment offset perform the rearrangement of data with the help of identification field and more fragment field. More fragment flag. Is it clear for everyone? So, Lakshman, can you tell me why we are using both identification field and more fragment field? We can use single one, more fragment. If more fragment is zero, it means nothing is coming. Then why we are using both?
Uh, Sir, I think identification field helps to that, like it helps to rearrange the data, and more fragment here used to indicate it is the end chunk. Any more chunk will not come, like that. I think so.
Maybe
Subhaji?
like more throughput is coming when you have like a more fragment, right?
Yeah, yeah. Let me give an example to you guys so that it will be clear. Suppose that it's a fragment F1 with 0x001, 0x002, F3 0x003. Suppose this reach at the destination first and it has more fragment field 0 and it reaches first. It reaches first. So by seeing this identification field that the number is 3 here, the receiver can understand I have not received the 1 and 2. I have to wait. Okay. But by seeing this field, receiver can understand this will be last. Okay. Suppose that after that receiver is receiving F1 0x001 and the last it is receiving F2 0x002.
So
So now by this field he will able to rearrange the data, and by this field, more fragment field, receiver can observe that all the fragments has came here. Okay, is it clear?
Yeah. Okay, sir. Yes, sir.
Subhajit,
yeah,
Abdul,
yeah.
Yes, sir.
clear?
Okay. Yep.
Okay, so these are the very important things. These are
Sorry.
8 bits of priority and type of services, protocol flag and fragment offset. Anyone who has any doubt, he can ask to me.
Sir, but I not understand the fragment of the diagram example. One more time
This
so
one,
that I can.
you are saying this one?
Yes, sir, fragment offset.
This one fragment offset. I discussed this fragment offset here.
Yes, sir.
So you can, so suppose that these are three fragments. Okay,
Yes, sir.
these are three fragments for which fragment offset bit for this fragment is 0. For this fragment it is 1 fragment offset bit. One, sorry, more fragment bit. For this more fragment bit is 0. For this fragment more fragment bit is 1. For this more fragment bit is 1. It may be possible this packet will reach to destination first. If it directly reach to the destination first, then once the receiver will see that this one is 0, then it will understand no other fragment will come. But by seeing this identification field, you can understand this is the third number. First two number are missing, and so it will wait. Okay. Then if
Yes, sir. Now,
first is
yes, sir.
coming,
Now understood. You.
then it will and understand. Let's wait for second one. Now second one is coming.
So it's not going to like transmit the data, right? Until it receive all of those, right? In sequence order.
Yeah. Without if suppose that you are sending a data, I have to open a new tab. Suppose you are sending a data from router R1 to router R2 to router R4. So you are sending suppose three fragments. Fragment 1, 2, 3, 4. From here to here. PC1 to PC2. So first it will come from PC1 to router 1. Router 1 rearrange the data and then it will process and send it to router 2. Router 2 then will rearrange the data and will send it to router 3. Router 3 will do the same job and then it will send to the router R4 and now it will come. Is it okay? Have you ever seen you have written down a message, suppose that, and you are sending it to uh, someone from WhatsApp? Hello, how are you? Have you ever seen how delivered, then you delivered, then are, then hello, or in a proper manner? Hello, how are you?
It will be in a proper manner.
In a proper manner, with with the help of this method, we are able to deliver the proper data. Is it clear?
Yes, sir.
Like if you are writing a paragraph here, the same paragraph will be delivered here. Sometimes in emails you can see there is a notification you cannot write down more than 250 words, or in a message on WhatsApp. So one fragment will be for 250 words. Have you ever seen in writing your updates, status updates, you cannot write down more than 80 words or 100 words or 150 words. If you will write it, then it will make another fragment. Okay?
Yes, sir.
Now is it clear for everyone?
Yes.
Yes, sir.
Okay. So the next field will be protocol field. Who will tell me what is the value of the protocol field? Protocol will let you know which protocol you are.
Maybe that include the TCP UDP protocol, is
No,
it?
no, at layer 3. We use at layer 4, TCP and UDP. Which protocol we are using at layer 3. Okay? Is it clear?
Yes, sir.
So, who want to describe each and every field, whatever I have discussed in IPv4 header?
One more doubt in flag IP header. Totally, there are four division like reserve, donut fragment, more fragment, then fragment offset.
No, no,
Like
fragment
yes,
offset is separate field.
oh yes, sir.
Fragment offset is a separate field. It's not a flag. There are only three flag. The reserve
Yes, sir.
flag,
Yes, sir.
do not fragment, more fragment. Is it clear?
Yes, sir. Clear.
Okay. Subhaji, would you
Yes, sir.
like to explain about the
But
IPv4 header? So you have to
I realize,
explain
sir.
version, header, priority, and other three
Version
field
means
total length, identification, and flags will described by
which
Abdul.
version we use in the three.
Okay, start Subhaji.
So in version field, we know that which version we use, IPv4 or IPv6.
Abdul, why do we use the priority and type of services field? What are 8 bits in priority and type of services?
Type of services which has like 8 bits, and this field like mainly deals with information about the quality of service, and the first 3 bits provide the prioritization of the IP packets depending on the certain service needs, as like delay or throughput. uh,
Reliability,
yeah, reliability as well, yeah, type of
cost,
service. Yeah, cost as well, yeah, right.
and last one is reserve purpose.
Or reserve as well, okay, yeah.
Do you know about the cost? What is cost? Subhajit or Lakshman, what is cost?
Cost. It is a value of the specific link.
The different protocols have different parameter to calculate the cost. Okay,
Yes, sir.
so these are very important field of IPv4 header. So if on Monday I want to take an interview session, so how many people are ready? Whatever we have discussed and whatever we discuss in next class.
Sir, actually, I think we have not discussed cost.
Yeah, we will discuss about the cost in upcoming classes.
Yes, sir.
Don't worry about that.
Monday, I am ready, sir. I will prepare before Monday. What are the concepts you have
Voting
taken?
process, subnetting.
Yes,
Abdul,
sir.
are you
All
ready?
concepts.
Subhajit,
Yes, sir.
Abdul, are you ready?
I can give it a try. Yeah.
It means you are not confident. Okay. So the next will be UDP header. Anyone who knows about anything? UDP header is most simple header. Why do we use UDP? Ravi Shankar. And which protocols use UDP?
DCP.
It uses the same, like,
No, no, I am asking with Ravi Shankar.
the.
Ravi Shankar,
हाँ सर.
can you tell me about the
हाँ.
UDP and which protocols use UDP at layer 4?
DNS, DHCP, DP.
Yes. So how UDP works?
ODP.
It's a very simple question.
Source and destination ports.
These are the four fields. It is also 16-bit fields. Lakshman, by seeing these four fields, would you like to explain it?
Yes, sir. And these all fields are already in TCP header.
Yeah, that is why I am saying.
Whether I need to explain it.
Explain about these
Hello,
four fields.
sir. You are not audible.
Am I audible to you, guys?
Sir. Now audible, sir.
Okay. Explain about these four fields. Yesterday we have
Yes,
discussed
sir.
in TCP header.
This source port number helps to identify which protocol is being used at layer 7. and destination port number helps to identify the destination port number. Length field indicates the size of the actual TCP header, like a UDP header here. Uh, it can be from 20 to 60 bytes. Then checksum. It is used for error detection. Sir,
Yes. Abdul,
Yeah.
would you like to explain it?
Source code is very, it's like very self-explanatory. Whatever he said, like source code is like which um what you call, which added the source, with the ports, or the protocol, and obviously the destination port is like whatever the destination port is in any protocols like HTTP. If the information is coming from the source to the destination through the using the browser HTTP or any SMTP in any protocol, this way you can identify from from the source to the destination. You can identify from, and it is consists of like how many 16 bits.
Okay. So UDP header is clear. I think there is no need to explain it. Subhajit and Ravi Shankar, is there any need to explain it?
No, sir.
Lakshman?
Okay, sir.
sir, my explanation is correct
Yeah,
or
yeah, your explanation is
something.
correct. We have already discussed these fields in TCP
Yes,
header.
sir. No, sir. Then we can go to switch on to other topic.
Okay. So guys, I am going on. We are going on 10 minutes break. Okay. Again, I will send the link and you will have to join. Okay.
Yes, sir.